Alright guys, before we move on to the lesson of probability of simple events and its complementary, I'm going to show you what you're going to be creating as we go along with our notes. Now each of you is going to have a Cornell Note worksheet, and our essential question is, how can we predict the outcome of future events? Okay, so that is the main goal we're trying to teach you in this lesson, and along the way we're going to be answering questions as we go. What is the difference between probability and sample space? When can you classify an event as random? And explain how to determine if two events are complementary. Okay, now down here, once you've answered those those three questions, down here you're gonna come up with two of your own questions, and it says write a question using the DOK 1 and 2 question stems and make sure to include an answer. Now don't panic, DOK is going to also be given to you. Now it's just a bunch of question stems. Do not ignore the bottom 2, 3 and 4. You're going to be using the top 2, and you're going to create a question using some of these. You're also going to give us the answer. So that's going to be on the bottom of the Cornell Note sheet, as well as when you finish with that, the summary. And finally, for your homework, you're going to be graded on a rubric. This is going to be a rubric that you will also have with you, so you know how you're going to be graded even before you turn in the assignment. Now that I covered all of that, I'm going to move on and start with the lesson. Alright guys, now we're ready to start on probability of simple events. Now before we begin, I'm just gonna review, and remember, a sample space is the set of all possible outcomes. Okay, now probability is the chance that some event will occur, and a simple event is one outcome or a collection of outcomes. So after all of this, what is an outcome? So our math definition states that a possible result in a probability experiment. Now that sounds very fancy and very high level. So let's just put it in easier ways that you can relate to. So our real world definition is the way something turns out. That is our outcome in simple terms. Now we can see some outcomes when we move down and go to our real world link. So for a sledding trip, you randomly select one of the 4 hats shown below. Now we have these 4 hats over here on our side, and complete the table to show the possible outcomes. Well, outcome number 1, I have a green hat. Outcome number 2, I'll have a blue hat. Outcome number 3, I'll have a red hat. And outcome number 4, I'll have a purple hat. So those are my 4 possible outcomes. So now I have to write a ratio that compares the number of blue hats to the total number of hats. So I need to write blue hats to total number of hats. So I have 1 blue hat, and I compare that to 4 total hats. Now I'm writing it as a sentence so that you guys can see that this is the way a ratio is. 1 blue hat to 4 total hats. Now we express the ratio using our fraction, 1/4. Okay, so now we have to describe a hat display in which you would have a better chance of selecting a red hat. So I can create anything I want. So if I say I had a drawer with 5 red hats, and 2 blue hats, that will give me a better chance of selecting a red hat. Now we're ready to move on to the next page. So here on the top of a page we have our key concept, probability. So the probability in an event is a ratio that compares the number of favorable outcomes to the number of possible outcomes. And the number of favorable outcomes represents the sample space. So if we have an event, our probability of whatever event, it will equal to our number of favorable outcomes over a number of possible outcomes. Or to put it in easier, it's what we want over total possible. That's what it means. So if we want the out of the 4 hats that we had from the first page, if we wanted 1 red hat, we want the hats that at the top. That'd be 1 out of total possible 4 hats. That's how we get the probability 1/4. Okay. So now the probability of a chance event is a number between 0 and 1. That expresses the likelihood of the event occurring. Greater numbers include the greater likelihood. So now you're assigning it a percent or a statement saying how likely this was to happen. So if we go back to our hat exercise, our hat example from the beginning, and we see that we have a possibility of 1 in 4 to get a red hat compared to all the total hats, we see that our probability is unlikely, or we have a 25% chance of selecting a red hat. Now, to go with that, if outcomes occur at random, each outcome is equally likely to occur, which means that we could get each hat with the same amount. So each of them is 1/4, so they're all equally likely to occur. Now let's go on to example 1. Okay. Example 1 is fairly simple, and we're dealing with a number cubed. Now there are 6 equally likely outcomes if a number cube with sides labeled 1 through 6 is rolled. So we need to determine P, or the probability of rolling a 6. How likely is it to roll a 6? So let me cover this up so I can go ahead and work it from the beginning. And let me keep that out. Okay. So when we think about a cube, we're thinking about dice. And when we think about dice, we want to know the probability of rolling a 6. Let me change the color for because this is too light. Okay. So we want the probability, there we go, of rolling a 6. Okay. Now when I look at a number cube, I see that I have 1, 2, 3, 4, 5, and 6 as possible outcomes. Now remember, it's what we want over total possible. So when I have the probability of a 6, I know that I have one side that has a 6 over 1, 2, 3, 4, 5, 6 possible sides. So my probability of rolling a 6 is equal to 1/6, which is right here. And the probability of rolling a 6 would be equal to about 17/100 or 17%. So now if I go back to my diagram up here and ask myself, how likely is it to occur if I have a 17% chance of rolling a 6, I see that it's even smaller than unlikely. So it is unlikely to roll a 6 given a 17% chance. Now you go ahead and work out the got it, and then we'll move on to the next page whenever you're ready. Now we're ready for example number 2. And example number 2 builds a little bit upon example number 1. So again, we're working with a number cubed with 6 sides, 1 through 6. So we need to determine the probability of rolling 2, 3, or 4 on a number cube. Now this word "or" takes this to a whole new level. So now we're not looking for one number. We're actually looking for the probability of 2, 3, or 4, which means we need to land a 2, a 3, or a 4. So again, it's what we want over total possible. So when I look at this, I see that I want to land on a 2, a 3, or a 4. So we want a possible 3, because I'm not talking about this number, but 3 sides, the 2, the 3, or the 4 is what we want. We just want to land on a 2 or 3 or a 4. So that gives us 3 favorable outcomes, or that's what we want. One of those 3 numbers. Now total possible numbers, we have 6 sides to our cube. Now we have 3/6. The only thing is we can never leave probability in we always have to simplify fractions. So I have 3/6, and I see I can simplify by 3. So my probability, or my probability of rolling a 2, 3, or a 4 is 1 in 2. Now that is rolling a 2, a 3, or a 4. My probability is 1 in 2, or 50%, or 0.5. Which I just noticed is right here. So the probability of rolling a 2, 3, or 4 is 1/2, 50%, or 0.5. Now you use your spinner here to try and determine the probability of each one of these events. And when you're ready, we'll move on to the next example. Alright, so I jumped the gun a little bit, and before we move on to example 3, we need to determine the probability of a complement. Now the complementary events are 2 events in which either one or the other must happen, but they cannot happen at the same time. The sum of the probability of an event and its complement is 1 or 100%. It sounds a little bit confusing, so if we need to clarify it a little bit better, a complement in everyday language, complement means the quantity required to make something complete. This is similar to the math meaning. If you're still a little hazy, let's go on to example 3 and I'll show you exactly what we're talking about. Okay, now we're here in example 3. Now let me go ahead and cover this up really quick. I'll cover this up too, and then we'll go over the rest right now. Okay, so what we need to know is we need to determine the probability of rolling and not rolling a 6 in example 1. Describe the relationship between the two. So the probability of not rolling a 6 and the probability of rolling a 6 are complementary. So the sum of the probabilities is 1. So let's put it in terms that we can see it. If we have the probability of 6, we also need to have its complement, which is the probability of how many are not 6. And if we add these two together, we get 1. So now we replace what we have before. So we knew from example 1 the probability of rolling a 6th is 1/6. Plus, we need to add that to the probability of not rolling a 6. And that'll give us 1. So now, we have 1/6 is our probability of 6. So if we're rolling a dice and our total possible outcomes is 6, and we want a 1 favorable outcome, how many of them are not favorable, or how many of them are not what we don't want? Well, if we think about it, 1 out of 6 is what we want, so then 5 out of 6 is what we do not want, and that'll still give us 1. So that is its complement. 1/6 is the probability of rolling a 6th, and 5/6 is the probability of rolling everything else we don't want. So let me get rid of it here so we can read this together. So the probability of rolling a 6 is 1/6, and the probability of not rolling a 6 is 5/6, or about 83%, or 83 hundredths. Since the sum of the two probabilities are equal to 1 or 100%, they are complementary events. So when we rolled the probability of 6, we had a 17% chance. And when we had the complement, which is 5, 6, we had an 83% chance. If we add them up, we have 100%, which is exactly what we wanted. So now go ahead and try this got it and see if you guys can figure out the probability and its complement. And when you're ready, we'll be moving on to example number 4. Alright guys, now we're finally ready for our last example, example number 4. Example number 4 says Mr. Harada surveyed his class and discovered that 30% of his students have blue eyes. Identify the complement of this event, then determine its probability. So we know that 30% of his students have blue eyes. We need to identify the complement. So the complement of having blue eyes is not having blue eyes. The sum of the probabilities is 100%. So the way we can do this is we have the probability of having blue eyes is added to the complement, which is the probability of not having blue eyes. And when we add those up, we have that equal to 1 or 100%. Now that's a horrible or, but we'll just go on. Okay, so we know the probability of students that have blue eyes. So we know that we have 30% of students have blue eyes. And we're going to add that to the complementary of not having blue eyes. Which is equal to 100%. So we have to think to ourselves, if we have 30% of the class with blue eyes, how much more do we need, or how much of the class, what percentage of the class does not have blue eyes? And if we add those two together, that should equal to 100%. So here it's easy to see that we have 30%. When we add that to 70%, and that'll give us 100%. So here we can see that the complement of 30% of the students that have blue eyes is 70% of students, and they do not have blue eyes. Now the probability of that, and we can see right here, so the probability that a student does not have blue eyes is 70%, or 7/10, or 7/10 as a fraction. Now before you guys move on, your homework is going to be on page 374, and you're going to be working numbers 14, 15, 16, and 17, as well as completing this Cornell sheet. Okay? Alright guys, so hopefully you guys get it, and we should be having a great class tomorrow.